Good afternoon and good evening for the professors and students. I'm Xiaoyan Zhang. I'm from Sydney University. Today the talk is about the image restoration and enhancement based on deep learning. I'm not in the area of bioimaging. I'm from the computer science and engineering. So our work mainly focus on the technology and the application. Uh, uh, but I think the issues we still have in the bioimaging, for example, the noise and the haze. These are the problems for image restoration. The technologies in this area also can be applied for the image processing in the bioimaging sensors also. Another application is to enhance the image appearance, for example, to increase the visibility of the image or changing the lighting condition or directions of the image to make it looks captured in another environment. About the technologies, we will mainly focus on these two methods, the deep learning methods. One is the generative adversarial networks. I think we all know the GAN models. It is popular these years. We have used the GAN for the image restoration to denoising the haze. Another method is about the deep reinforcement learning. The reinforcement learning methods is popular in the game. Yeah, we all know a lot of research in DeepMind, they use reinforcement learning. But it also can be used for image processing. So we do some work for the image relating. Then I will give details of our research. First, about the GAN model, I think we should know something about it. It contains a generator and also a discriminator. These two are trained to contact each other. The generator try to generate a real image. The discriminator try to recognize the real and the false image. Yeah. The discriminator can be seen as a policeman. They try to recognize which is real, which is false. But the generator try to fool the discriminator to let it make the wrong decision. So based on this context training, the generator can generate the real image. Yeah, the quality is high. But we cannot only depend on this, only the generator and the discriminator loss between them, but we also need to preserve the details of the image. Therefore, we need ground truth to train the model to minimize the mean square errors between the pixels. Therefore, this model needs to train based on ground truth. It is a supervised method. Yeah, this is the problem. This is the problem in the image processing. For example, in this application of the noising, we need to know the noise image and also the paired clear image. This is the limitation of the application. Can we do some research without the ground truth? Yeah. Yes, there another model, but again called circle GAN. It can be used to train unsupervised. Yeah. Our group, Professor Shi has also do something using the GAN models for the cell image denoising. This is some examples. This model is also trained based on ground truth image. For the unsupervised models, what can we do? And some researchers have developed a token. It uh, it can be trained with unpaired image. It uses one group of images with the noise or haze. Another group of images is clear without noise, without haze. Based on these two groups of images, it can be generated our expected the noise of the hazy image. We use this cycle guide on the image enhancing problem because it has affected the readability of our image. Also, in the application of image content recognizing analysis, we also need to know the real content. So we need to make the hash away. Yeah. So the health model is a physical model. It can be removed by using atmospheric physical models. But this model is simplified models with a lot of assumptions. So the results are noisy and it cannot be worked for the scale region. So the results is not there widely the performance is not such good. So another way is try to learning based on the paired image. The paired image is the image with head and also its corresponding image without the head. Based on this paired image, we can train any deep learning models to generate the enhanced image. But the limitation is it is very difficult to acquire this paired image. So our objective is trying to train without the paired image. We collect a group of haze image and another group of clear image with blue sky, beautiful from the online. They are unpaired. The contents of them are different. We want to use the cycle guide to reduce the haze from the first group of image to generate an image with blue sky, beautiful. Yeah. The cycle guide is have two generators and two discriminators. This is the model of the cycle guide. The X we can see X as the image with the haze. Y is the image without the haze. The first generator is trying to remove the haze from X to Y. Another generator is trying to add haze from Y to X. Yeah, one is to remove the haze. Another generator is trying to add the haze. In the forward training, the image with haze it will pass generate and to get the haze image. The haze image will be passed to another generator to add the haze again. The added haze image will have should have a consistent a content consistent with the original image X. So based on the circle constitution laws between the generated image, it can use the unpaired image to train the model. Now, in the regression stage, we only need to generate the first generator to pass X to Y. Yeah, this is the main idea. We use this cycle guide model. We trained our enhanced model. Of course, we design a lot of loss functions to make the image to make to be the get our expected effect. Also, there is a problem. There is a problem in this model. Is that the because without pixel to pixel loss, without the ground truth supervising, the content may have some artifacts. To remove the artifacts, we need some only some paired image. So we collect only a small number of paired image to aid in this model to constrain the model to generate a more realistic image. These are some results generated by our circle-gun model. The image in the top row is the erased image. The second row is the image generated by our model. This model, we don't have the ground truth of this the image in the second row, but we can generate the image without hands. So the advantage of this subguide is that it can be used for unsupervised learning. I think this is have a lot of applications of this model. But the GAN model is also a black box filter. We can see it as a black box filter. We don't know what is done in the filter. But sometimes we want to know what is done in the process. So how can we know the steps in the process? The reinforcement learning can give us the process. It model the process as a sequence operation. We can know what is done in each step, like again. So we use reinforcement learning to do some image processing, and we know what is selected in each step. The reinforcement learning is popular in the game. For example, in the DeepMind in 2005, it's proposed a model to play the actual game. And the network agent to predict the actions it will do in the next step. It contains the agent is trying to predict the actions it will select in each step. It observes the features from the state, the environment to get features, and then the agent will make decisions to predict what it will do in the next step. For each step, it will give a reward. The objective of this model is trying to maximize the expected long-term reward. To maximize the reward. There are some related works about using the reinforcement learning for image enhancement. For example, this is a work in CPR 2018. It used the reinforcement learning to select filters to enhance the image. Usually, we may want to change image using a PS. We may change the brightness, the contrast, or the color saturation, something. The model using reinforcement learning can to predict the filters step. It will predict which filter you will select and the parameters of each filter, and sequentially they will get the expected results. But this model is these filters are global features. They only can change the parents globally. How to change the image locally is another work called pixel reinforcement learning. It models each pixel as an agent. For each pixel, it is supposed to be filtered by different filters in the denoising. So the model define a lot of filters. For example, the Gaussian filter, the media filter, and the literal filter. For each pixel, and it will select for each pixel, it will select a filter. Here we see this colored image. This color, each color expresses one filter, one kind of filter. But you see the different filters for each pixel, the image can be recovered, restored to reduce the noise. this work is to do the denoising locally. What we do is to do another application trying to change the appearance of the image. For example, the relating. The relating is to have two applications. One is when we have the illumination condition, we want to change an image to another image illumination condition. Or if we have one reference image, we also can change the lighting condition based on the reference image. Also, we want the precise to be locally effective and the scale invariant, and also interpretable. So we model this precise like a painter. A painter too, like artists to paint an image step by step. You only need to choose the brush where you need the shape of the brush and where you can paint. The reinforcement learning can help us to predict the brush at each step. So we model the agent, the network, we predict the parameters for us. The parameters can control the shape of the brush and also the shape, the location of the brush. We use the brush to render image. Step by step, we will get the related image. This is our model. However, about the brush, we use either a curve to simulate the shape of the brush. These parameters, the action is the parameter to control the shape and the lightness of the brush. We based on the parameters, we can render we can render the brush. The brush can do the dodge or burn operation on image. A dodge is trying to bright the area you want to paint. The burn is trying to dark the area you want to change. Based on this operation, and also we define some reward to control our selection of the parameters. Here we define the pixel to pixel difference as a reward. Also, we give the constraint on the seeding because in the relating operation, the seeding is the most important factor. Another is we try to simulate the process of the artist. They always paint from close to fine. Therefore we find a reward to let the agent to select a brush from a cost to fine also. This is the example, one example what the selection of the brush. Let me see. We say when we select in the process, we select a different brush. Based on the brush, we can change the image step by step. In the previous applications, the light condition is based on the SH lighting definition. We also relate the image based on our reference image. This is an example. Yeah, based on the reference, we can predict the brush at each step and change the image. Okay. This is another effect also. And we can change step by step. Also, based on this, we can change image to any direction you want. Yeah, any direction, top to down, left to right. This is another example. Change the direction from left to right. Okay. Another advantage of the reinforcement learning is that it can do precise for high resolution image. We know for the general CA models, the limitation is that the input image size is limited based on your computer computation ability. Mostly it is limited to a size of 500 times. But in our model, because we do not change the image directly, we only predict the parameters to control the change of the image. Therefore, our parameters can be directly used for any resolution image. Yeah, this example we do the prediction based on a small image, for example, 256. But we can use the filters also to high resolution image about 2048. Therefore, this method can be used for high resolution. About the reinforcement learning, it also have other operation. Another is if we have multi-module data, we have a multi-module data. We can get information from different type of data. How can we combine all this information together? Another way is to use the different channel, multi-channel agents to predict our results or process our image. Firstly, separately to get information and then interact to change to share information to finally give the decision or process. This is another model we used for the cropping of the image. Okay. The previous two work is two models we use currently in our image restoration and enhancement. We also do some work trying to use the hierarchical reinforcement learning models to do the image processing and also, for example, the restoration and enhancement. Here I give one example. It's from DeepMind. And the manager is trying to select agents. The workers is some previously trained models. They do different operation of, for example, the denoising. They do different type of denoising. We can use the manager to select your models adaptively to do the final processing. Another work is we also try to do some sensor image processing. For example, now one popular sensor is the 3D camera sensor. The 3D camera sensor has already used in the phones, for example, iPhone. The sensor, one popular sensor is the time of flight depth sensor. However, this kind of sensor do not perform well in the outside. They can work well in the room, but when they move out to the outside, the performance is very poor. We only can get some sparse data of the foreground. We miss a lot of data of the background. In this situation, how can we restore the information, the missed information? Here we try to use the deep learning models to estimate the missed information and to reconstruct the 3D scene. This is another work what we are doing. Okay. This is the papers about our work related to my talk about the image enhancement and restoration. Okay, this is my talk. Thank you. Some questions?
Hello, Yuji. Can you hear me?
Yeah.
The talk is complete.
Hi, thanks for your presentation. My question is regarding your part on de-hazing. So you said that you have paired and unpaired images. My question is, are the paired images real or synthetically generated?
In this area, we have both. Yeah, someday we have the paid data from review. And also we have some data from synthesized. For example, this here I show only one example of paired data. The clear image is captured in view, but the image with head is a synthesized one. The head is synthesized based on the depth of this image. So usually in the enhancing we use the synthesized data because the real image data size is very small. So we need to synthesize the hazard factor for train the models.
All right, thank you.